Okay, so continuing with description for a quantitative variable, we're going to compute the sample mean and the sample standard deviation. The mean is just probably what most of you normally think of as average. Add up the values and divide by the number of them, you get the average or the mean. By sample mean, we mean that we're calculating it. The mean that we calculated is based on sample data, not an entire population of data. The sample standard deviation kind of goes along with the sample mean. The sample mean tells you where the middle of the distribution is, and the standard deviation tells you how spread out the values are. So I'm just going to start with a problem. The sample mean is x bar, and it's equal to the sum of the x's, the sum of the values for our random variable, divided by n, where n is the size of the sample. So in this sample we have 1, 2, 3, 4, 5 values, so n is going to be 5. Now I think in your book it might do 1 over n times the square root of x sub I. You certainly can write it that way. I prefer the way I have it written over here, that the sample mean is the sum of the x's, or the sum of the x sub i's, which is just the individual values of x, divided by n. And so I'm going to add up these values here. I get 35. That's the sum, and there are 5 of them. The sample mean is 7. So we're going to go on now to compute the sample standard deviation. I'll write the formula in a minute, but what I'm going to do is I'm going to come over here, and I'm going to make a column of the x sub i's minus x bars. These are the deviations, or the deviation of each value from the mean. So all I'm going to do is I'm going to come over here and I'm going to subtract 7 from every value of x. So 6 minus 7 is minus 1, 9 minus 7 is 2, 11 minus 7 is 4, and so on. This should always sum to 0, which it does. And what we'd like to get for a spread is something that's like an average spread around the mean. We won't exactly be able to get that because the average spread around the mean is always going to be 0. So we're going to have to find some way to get a non-zero number. So I'm going to take all the deviations and I'm going to square those. So minus 1 squared is 1, 2 squared is 4, and so on. So these are called squared deviations. And I'm going to then just add those up. And I get 38. The sample standard deviation, it's going to be this, the square root of this sum divided by n minus 1. Let me write that out for you here. S is equal to the square root of the sum of the squared deviations, that's the 38 that we have down here, divided by n minus 1. So it's going to equal the square root of 38 divided by 4. I get 3.08 for that. First of all, I'll begin by just adding these numbers up, and I get 36. And there are 6 numbers here. So the sample mean is equal to the sum of the x's divided by n, which is 36 divided by 6 is 6. Make sure that you write down the symbol, the formula, that you put the numbers into the formula, and that you then have the solution. And of course, if you're an accounting major, you have to double underline that solution. The rest of you can just leave it like that. So anyway, now I'm going to get the deviations. I'm going to subtract that sample mean from every value on here. And that does sum to 0. Then I'm going to square those deviations. I'm getting 60 there. And so the sample standard deviation is equal to the square root of the sum of the squared deviations divided by n minus 1. That's equal to the square root of 60 divided by 5. There's 6 values minus 1. So the square root of 12. One other thing I do want to say while I'm here is there's another measure that's related to the standard deviation that we'll sometimes use, and it's called the sample variance. And that's S squared. So it's the same formula as above, except for you don't take the square root. One of the main reasons we'll use the standard deviation is that it's going to be in the same units as whatever our value of x is. So if these x's, this 3, 6, 2, and so on, if those were dollars, then when we get down to the variance here, that 12 is 12 squared dollars. And I don't even know what a squared dollar is, although we will still use that 12 somewhere later in the class. But when you take the square root of it, I've got one more here. Add these up, and I get 49. And there are 7 numbers there. So the sample mean is equal to the sum of the x's divided by n, or 49 divided by 7 is equal to 7. Then I'm going to subtract 7 from each value, get the deviations. That does add a 0. Then I'm going to square the deviations. I'm getting 60 again. So anyway, to get the sample standard deviation, I'm going to take the square root of the sum of the squared deviations divided by n minus 1. That's equal to the square root of 60 divided by 6, the square root of 10. If you wanted to take the variance, it'd be s squared, and you just wouldn't take the square root. S squared is going to be 10.